Unknown.
Unknown instrument. Okie doke.
Not configured.
Someone was paying attention this morning. Exactly. So what we'll do is we'll go to our configuration. It's got a configuration here, but what we need to do is disconnect. This is called, if someone tells you to blow out the configuration, this is what they mean.
It's done.
Yeah. Let me close out of this. It's not happy.
Should we turn on the this one first and then turn on the computer?
This needs to be connected. I'm going to close out the software and then reopen it. If it'll let me do that. It's really not happy. Yeah, really not happy. Let's just do a restart real quick. And while we're over here, our oven temperature should be set to 68. Doesn't matter if that is set to 68. That's on. That's on 200 degrees. We'll set this, we'll turn the heater off. Cool. See, we don't have an instrument anymore. We need to configure it. Okay. The name, we'll go to File, we'll go to Instrument, Configure, select the COM port. Port for type. First time's a charm, love it. Alright, hit continue. Port A is where we're configuring it. Remember, we need to select the GC. So this is a 590 without auto sampler. And we want to configure. We don't need to fill any of this out, we just need to hit OK. And then we click, see the configure check mark, and then we can hit finish. And this process is going to take 3 minutes. If you want to start a timer, it's 420.
So when we do the increase the FID temperature, when we change the FID temperature?
The FID temperature?
Yeah.
I turned it off the other day,
Mm-hmm.
and so it's just, why is it not responding? Something's not happy. You would turn the FID temperature on before you want to run a sample. It's turned off just because it was sitting there in standby. TurboChrome may not have been happy when I turned the network off. don't know why that would affect anything, but it's not responding. It's going too smoothly. From the top. Cone's not happy.
So to get the temperature into 450, it takes 2 hours. Just to know.
To 400?
Yeah, this is what we will set for FID temperature.
Methanizer.
Yeah, methanizer.
It's probably going so initial startup,
What temperature we should set?
400
400. Okay.
for the methanizer.
Methanizer. Okay.
Yes. Now, you need to go through the process, right, of conditioning it for 2 hours.
Yeah, I know.
With just hydrogen,
And then
and then we can bring the temperature up. So then, after those 2 hours, you can add the argon carrier gas. And so I would do that by having the system with valve 3 on, and then have hydrogen running at 45 milliliters per minute from the FID through your methanizer for 2 hours. And then I would, on auxiliary 2, increase the flow to 30 mils per minute.
yeah, show me here. I need to learn these things.
Yeah. And so I would have on your FID
Okay.
hydrogen at 40 milliliters per minute. So we set hydrogen to 45 milliliters per minute.
Yeah. Okay.
Okay. Let that do its thing. Our auxiliary, our relays, we want valve 3 on.
Okay.
And on our auxiliary gas, we can have this flow set to 0.
Okay.
Auxiliaries are gone, right? Auxiliary is the argon from the valve 3, right?
Correct. Yes, sorry, I couldn't hear you. Yeah. And then I would set it like that for a solid 2 hours. And then what we're going to do is we're going to take this flow up to 30 mils per minute. If you had a flow meter, now you'd be able to measure that flow. So I can measure it. So we should get close to somewhere in the mid 70.
Yeah.
70, 80 mils per minute.
83.
Yeah, that's fine. That's good. And then we would bring our temperature up.
Oh, okay.
So first we set to 100. That temperature is going to increase. I'll take my FID. I'll turn my FID temperature up so I can get a signal out of it. And I'm going to turn the air on my FID up. Once the FID temperature gets to 200, you can light it.
So this is in the procedure for the startup, like the manual.
It's in the manual, yeah.
Oh, okay.
What I wanted to do is have the FID lit because you're going to want to see your background signal coming off of the methanizer. Once this gets up to temperature, I'll show you. You'll have the signal will be really high. What we want to do is let that come down to about 2 to 3 millivolts, and then we can take it up another 100 degrees in temperature.
Okay,
then-
so not directly 400 degrees, slowly,
Yeah.
step by step. Okay.
100 increments. That's outlined in the manual. Still trying to configure over here. Hopefully we're happy this time. Okay. For A. Wait, that? Interface on. So this is where it can give you a bit of the runaround where if it's, there we go. It was saying interface not found. It does that sometimes. You have to back out of the acquisition port, go back in and try it again. I made a mistake here. Instead of having a 5, there we go. We want the 590 in that auto set. And now we don't touch anything, we just let it do its thing. I made the mistake of trying to do something else in the background while I was configuring, and that's what it didn't like. Okay, what temperature are we at? We're at 170, let's try to light this. The FID is lit. So we see the signal's climbing.
Okay.
It's going to climb, and then it's going to come back down. And then once it's kind of stable, we'll increase it 100 degrees. Now, we're not going to take it all the way up to 400 because it's going to take it hours and hours to cool down, but that's the process.
Okay.
So if we go into our manual, operations manual, and we go to conditioning methanizer. So this would be the step here. So we want to light the FID, right? And then we want to turn the heat up in the methanizer in 100 degree increments. It's going to say let it come down to baseline. Two millivolts, 3 millivolts is going to be baseline enough.
So let's say it's coming from a shutdown method. When we turn it on, the method that will load will be the last shutdown method on the GC, right?
Yeah.
And then from there, we just slowly we follow this procedure to heat up the methanizer from the shutdown mode method.
Yeah, or from like, yes, essentially yes. The only thing that I would change to that is that you could turn aux to 0 when you start up, and that way you just have pure hydrogen going over your catalyst. It helps it regenerate and
SCS over there.
yeah. So just yes.
Yeah, it's 249 now. Yeah.
Oh yeah, that's fine. But we're talking that's the pack injector is what we're concerned about. This signal's gonna probably It might creep up a bit. It might stabilize. Certainly, when you get up to 200 degrees, there's two things that. Okay, we're gonna hit OK over here. Yes. If it's been sitting for a long time, especially in the summer, and you go up to 200 degrees right from 100, you might blow the FID out because there's a lot of moisture.
So from the shutdown method, do we still need to increase to 45 ml per minute the hydrogen,
Yeah, turn it to 45.
and then turn the valve off, right?
Valve on,
On,
valve 3 on,
valve 3 on,
but you can turn the aux2 gas off.
aux to gas off.
All right, now we're configured. It's in reconfig. It'll sit like in reconfig for a couple minutes. So now if we want, this has been stable now at 1, so we can take this temperature up to 200. And then you're going to watch the FID signal,
So what is this temperature then?
the FID detector.
Oh, so we just set 100 degrees Celsius. That is for what temperature?
That's for the methanizer.
Oh, the methanizer.
Yes.
Okay, so
Yeah. So there's the methanizer, and then your FID.
okay, so three different things.
Yeah.
One for TCD.
So there's two detectors, though. The methanizer's not a detector; it's just like another accessory.
I say.
Okay. So this is all set up. So if I hit take control, it should take control. Should say external. Perfect. This should increase. The millivolts will increase because the methanizer temperature is coming up. Okay. I'm going to release control. And you're connected and reconfigured.
So this one we don't have to touch anything this one.
No.
So only for channel B, channel A don't have adjustment.
Those adjusters are only for TCD.
Okay.
So
okay.
you only have one TCD.
Oh, okay. Yeah. Okay.
Yeah. And it has to do, yeah, with the lamp. You don't need to touch that. It should be
Okay.
set at like,
Okay.
That's
It's
the
a 5.
zero, the reference.
It's a 5.
That's 0 the reference of the PCB.
no, it has to do with the plant voltage, I think. I don't think it has to do with the reference gas.
Not like the 0, you know.
That's a lamp value.
Channel B is TCB.
Okay. What we're going to do is we're going to go and there. There's a 12-minute method that I just moved it over here. What we'll want to do now is, what are we looking at for? It's 11 millivolts. So it's going to go up, and then you're going to need to wait for it to come down to about 2 millivolts before we take it up another 100 degrees. We want to go through the process of measuring gas flows. So what I'm going to do is, I'm just going to cool the methanizer back down.
Okay.
And let's get ahead of that, so we're not going to be here. We'll just set this back down to 60. Actually, we'll just turn it off. That's fine. Okay. But what we want to do is target 32 mils per minute. I'm going to grab my notes to make sure that. Oh, behind it. That's the chat back there.
How come?
I don't know what happened to that.
Nobody touched it.
I was sitting out on the floor.
Maybe somehow it's production. Yeah, we will use the switch.
So we're targeting 32 mils per minute on the flow for aux 3 and aux 4. And to measure those flows, we measure them from the FID. So we need to go to the FID and we need to turn these gases off of it, right? So tools, configuration, FID. We need to turn this to 0, this to 0. While we're at it, we can turn the heat off of the FID. We don't need that on. We can turn that's off as well. Nice. Okay. I like to bring up the manual here to have a pressure too. In here, it's all laid out quite well. We need to do gas supplies. Checking and setting flow rates. The initial method, the 15-minute runtime method, is set to an oven temp of 65. Sorry, 60 degrees 0, 60 degrees Celsius. And there's a pressure flow chart here. These pressures only work if it's oven's at 60, so at 68 degrees oven temperature, we have different pressures to hit 32 mils per minute. That's what we're targeting. Okay, so what we want to do is follow report of turn aux 3 off. So there's no flow from the source, turn valve on. Is this the same game? Turn valve 1 on. What we need to do is we need to have start with all of your relays off. Okay. And so this means that we're getting column flow out the FID. Okay. Then we need to turn valve 1 on. Turn valve 1 on. So from the relays, we'll turn valve 1 on. And then we need to adjust our aux at is aux 4. And if we ever forget, we can revert back to the valve diagram and aux aux 4 with the valve on right now. We're setting up this flow rate. So we're setting up aux 4. We will measure it. I like to lift the lid up. I like the lid up because there's a restrictor right here that we're going to have to adjust. Okay. So with your flow meter, get the oven set to 68 just to confirm it. 68, perfect. We can turn this off. So we want aux 3 off because we only want to measure the flow coming from aux 4. Our target is going to be 32 mils per minute. To match the GC upstairs, it's 32.4 mils per minute. Upstairs, that pressure was 37 psi, 37.6. So let's try that. It's going to take a little while for it to stabilize.
So this is not milliliter, this is PSI.
This is PSI. We're measuring milliliters.
Okay, I see.
It's going to take a while for it to stabilize, like a minute or so. I think grab all the methods. What's the reading over there?
31,
Is it still going or is it stable?
31.1.
It's still moving a little bit. Really important one. bump it up a little bit. So with the methanizer cooling off, this might fluctuate a little bit. But should be stable, so it's at 32.7. We'll drop the pressure down a bit. 38.8.
Which flow rate you want to set it up?
Right in that ballpark. So we're at 32.3. Upstairs it was 32.4. I'm pretty content that we're there. So that shouldn't be that big of a difference on retention time. 0.1 goes from there. So what I'm going to do is take my pressure here, 38.7, and update the method, the instrument method, with 38.7 for aux 4. Okay. And then we'll do aux 3. And to do aux 3, we go to the next step. So we turn valve 1 to the off position, and then we set the pressure for aux 3. So we go here. And we'll close this. We'll go to our relays. We'll turn this valve off. Just turn it off. We'll go back to our aux gas and we'll set this. Upstairs it was 28.4. That'll be the starting point.
So no bulb is on now.
No.
Okay.
Do you have a 7/16 down here? I have one. If you don't. Oh, right there. What are those benches? Those look pretty good.
92. Okay.
This one's a little bit higher. Is that still the same? Okay, let's use a little more juice.
Four now. 5,
Yep.
6.
Maybe 30.5.
So you want to set it up what flow rate?
32.
Oh, 32.4.
Yeah, you try to target 32.4. Might be a little bit like 32.5, 32.3,
So this is auxiliary
3.
3. 31.
Oops. Yes.
And the flow rate here is the one in the manual, right? The flow rate you're trying to achieve here.
The one in the manual is set to 31. This is on this GC. The one upstairs, I guess. The one upstairs, I know the flow rates were 32 mils per minute. This one, they were set 1 mil per minute lower for when, I don't know when they set it up in the factory.
And then the 32.4 is the one you optimize.
Yeah.
Okay.
Yeah. And I was just trying to target around 32 mils per minute when I set that up. So we'll increase this pressure again to 30.
Can I take a look at the appendix D? In the PowerPoint. That's the PowerPoint. So it says appendix D.
Don't know, you want to go to meter 4?
Perfect. 34, 32.4.
So all this becomes 32.4,
32, 32.4, yeah.
and then the rest. This is a floating place, so there's no problem there. Right?
I left auxiliary 2 and didn't straight through most of it. The reference will stay 30 mils per minute.
So let's say nearly
Okay, yeah, so we use 31.8 in the method.
Okay.
And then the last step is to measure when we adjust the isolation valve, we need to set the flow with valve 2 on or off so that we get the same flow within 1 mil per minute. Can we go back to the method?
We need to test the this one as well.
And this is
Different for the counter speed.
I believe that it was set up already. I was told that it was this
Okay.
by Sebastian.
Okay.
Okay. So that's good. So what we need to do now is we're happy with those settings. We need to actuate our relays with valve 2. And if you watch the flow meter, when I actuate this valve, we should get a change in flow. It drops. And so we need to adjust, and now it comes back up. We need to adjust this restrictor so that the flow is within 1 mil per minute. So we're looking to get it down to 32. Now, it's a needle valve, so a small turn of that valve.
Yeah. Change it out.
Yeah, exactly.
So you'll bring it to what? Which
32 mils.
third? Okay.
Yeah, I mean plus or minus 1 mil per minute, right? We try to get as close as we can.
so this is always part and
Yeah.
France money to
Yeah.
buy equipment.
Yeah.
Yeah.
16.
It's gonna, and that flow, you see the flow comes up and comes back down. That's a spike that you see on the GC, right?
Where this out? In is here. Where it go out for this guy, for this toy? Where it out?
Inside somewhere, maybe.
Okay, just curious.
Yeah. Give 2 mils with it on and with it off. So there you go. That's dialed in. Yeah, I don't know.
Anyway, somewhere. Maybe everywhere.
To the battery maybe side?
Yeah, it's cooling down the battery.
Yeah.
Something, I don't know where, that's somewhere inside. Yeah, just probably straight up there.
Okay, interesting.
Okay, so that is set up. Those flows are set up in the instrument method. Save that. So 31.8 psi, 38.7 psi.
Okay.
So in theory, it should yield the same chromatography.
How often do we have to fact check the flow rates?
Only if you're changing the oven temperature would I need to confirm the flow rates. Like if you're making a new method and the oven temperature right now is set to 68. If you were going to try to do a different method, like where you're just measuring CO2 and you're not measuring hydrocarbons, you might want a different method. So you could change the oven temp, change the flow rates to optimize your method. And then the other reason to check the flow rates is if you see a big shift in your chromatography. Like maybe you want to check the flow to make sure that something's not plugged up, or for some reason there's an issue with the PPC. You know, if the PPC fails, your flow would be off, right? Like so, it's not something that's going to happen often. But if you run it, it's part of troubleshooting at that point. And then Ox is all good. FID is cooled down. TCD is cooled down. 80 degrees, 60 degrees. We can shut this off. This way.
So this is Jason.
No, this is just Nano.
Just not this one.
Jason is upstairs.
Jason is
Oh,
the third one.
Yes.
Where's the reactor for this one?
Sorry?
So there will be, that is portable. So they can anytime adjust, bring it here and then plug it in.
It will be here.
Yeah, the other side, yes.
Oh, cool.
And this is the